A rectangular coil of length 0.12 meter and width 0.1 meter having 50 turns of wire is suspended vertically in a uniform magnetic field of strength 0.2 Weber per meter square. The coil carries a current of 2 amperes if the plane of the coil is inclined at an angle of 30 degree with the direction of the field. The torque required to keep the coil in stable equilibrium will be. Okay, so according to the question, one rectangular coil is there. And here, if the plane of the coil is inclined at an angle of 30 degrees, that means one magnetic field, and this magnetic field is inclined at an angle with this rectangular coil is 30 degrees there. This angle is 30 degree. And a magnetic moment is there. Always it is perpendicular to the rectangular coil. This is magnetic moment and this is the magnetic field. Okay. And here the area vector is also acting because the area activity in which direction it is acting, the magnetic moment is also in the same direction. We know that one. That means M vector is equal to NIA vector. Area of the vector in which direction? In the same direction, the magnetic moment is also there. Then the magnetic field angle is 30 degree. Then what about this angle? This angle is, the magnetic moment is always perpendicular to the coil, that is the magnetic moment. Then if this angle is 90 degree and this field is 30 degree, then 90 minus 30 degree, which is equal to 60 degree. Then if I'm going to, we need to find the torque required in coiling the stable equilibrium. Then we know that torque is equal to, that is MB sine theta. Then we can write this one in terms of known terms NIAB sine theta. Torque is equal to. Then substitute the values. N is equal to 50 and I is equal to the magnetic field, that is 2, that is 2. 2, the I is equal to current, that is equal to 2, and the area is equal to, that is length and the width, that is equal to 0.12 into 0.1, and B is equal to 0.2 magnetic field into 0.2 into sine 60 degree. Then simplify this one. 50 into 2 is equal to 100 and 0.12 into 0.1 into 0.2 into root sine 60 is nothing but root 3 by 2 here. And if I want to remove all these decimal, then this becomes 100 and this becomes 10 and this becomes 10. Then if I simplify this one, 100 will get cancelled and 2 1 times and 2 6 times. Then 6 into 2 here is equal to 12. 12 root 3 divided by, we get the answer 10 into 10, 100. Then 12 root 3 divided by 100. If I am going to simplify this value, the value is 0.2 Newton meter. Then option C is the right answer here.